Okay, this is 4.7, and we're going to be talking about how to calculate the area of a regular polygon. Some terminology here, the word regular, okay, it just means that all the sides are the same in whatever shape it is, and the polygon is just a closed object with straight sides, okay? Any closed object that's got straight sides, and regular means that all the sides have the same length. So what are you going to need for getting started on this unit? Well, you're going to need a ruler. Okay, one that you can measure with. All right, let's do some try these. If you fold a square like this, you can find the center. What do you know about the four triangles? Well, we know that if we find the center, and it's a regular polygon, which means that all of these sides are the same length, because it's regular, means that all four of these triangles are the same size. So what do we know about the four triangles? They are the same size. Okay, so let's look at a little example here. Here's the definition of a regular polygon. It's a closed figure with all sides equal and all angles equal. So Jordana is making face pins shaped like regular polygons. What is the area of each pin? Well, you can see we've got three different shapes here. They're all regular polygons. This one is a square, which means that all four sides are the same. This one is six-sided. That's called a hexagon. Hexa meaning six. All six sides are the same. And this one on the right is an octagon, a stop sign. We've seen them when you're driving down the road. That means all eight sides are the same. The question is, how do we calculate the area? Okay. Well, how can you divide each shape into congruent triangles? What does the word congruent mean? The word congruent just means two or more polygons with the same size and shape. How can you divide each shape into congruent triangles? Well, we just need to know that, let's do the first one here. You divide into congruent triangles, all you do is you just connect the center of the shape to each corner. With a ruler and a pencil. Okay, so if I wanted to find the four triangles in this first one, let's call this number 1, number 2, and number 3. From the center, I go to each vertex, each corner, like this. I'll just draw dotted lines on it. You can see we have four triangles in there, and all four are equal. I can do the same with the hexagon. I can go from the center to each individual corner, and you will see that I have six congruent triangles, six triangles that are the same, and I can do the same thing with the octagon. Went to the wrong place there. And you can see that I have 8 triangles in that octagon. Okay, now you're going to notice that from the center down to the straight down to one of the sides at 90 degrees, that is the height of the triangle. You can see the height on this first one is 1.3, the height on the second one is 1.6, and the height on the octagon is 1.7 centimeters, okay? That is not the length of the sides of the triangle, that's the height of the triangle, because we're going to need that height, and we're going to need the base length to calculate the area of these regular polygons. Okay, so what is the area of each triangle within each shape? Because if I find the area of one of the triangles, because all the triangles are the same, all I need to do is multiply that area by the number of triangles, and I've got the area for the shape. So let's do the first step. Let's find the area of the triangle. So what is the area of each triangle within each shape? Well, in the square, the base is 2.6. Okay, so I'll write 2.6 here. The height is 1.3. And we know the formula for the area of a triangle over here in the margin. It's 1/2 base times height, or we can say base times height divided by 2. That's the same thing. Okay, BH over 2. So the area of the triangle is just 2.6 times 1.3. Divide that by 2. and we can find the area of the triangle. Okay, so let me get my calculator out here, and we can put it right there. There's the calculator. Move it over here, turn it on, cleared, and I can take 2.6 times 1.3, hit enter for equals, and divide that number by 2, and I get 1.69. So the area of this triangle, one of these triangles, is 1.69 centimeters squared. Okay, let's do the regular hexagon. In the regular hexagon, the base is 1.8 centimeters, the height is 1.6, so the area just of one of those triangles is 1.8 times 1.6, divide that by 2. Okay, so let's do that. 1.8 times 1.6, hit enter for equals, divide that by 2, and I get 1.44 centimeters squared. Okay, now let's do the octagon. Okay, we've got 8 triangles in there. Let's calculate one triangle. The base is 1.6 centimeters. The height is 1.7 centimeters. So the area of the triangle is just 1.6 times 1.7 divided by 2. Let's get our calculator out. 1.6 times 1.7 equals, divide that by 2, and I get 1.36. Okay, so that's the area of one triangle in each of those shapes. So how do we calculate the area of the entire polygon? Well, what is the area of each regular polygon? It's the area of the area of the square is just, we have 4 triangles. Okay, it's just 4 times the area of the triangle, which is 4 times 1.69 centimeters squared. And I get 4 times 1.69. And the area of that entire polygon is 6.76 centimeters squared. Okay, let's do the hexagon. Hexagon has 6 sides, so we have 6 triangles, and the area of each triangle is 6 times 1.44, 6 times 1.44, and I get 8.64 centimeters squared. 8.64 centimeters squared. An octagon has 8 sides, 8 triangles that are all the same. So we just take 8, multiply that by 1.36. That's the area of one triangle. There's 8 of them. So we take 8 times 1.36, and I get 10.88 centimeters squared. Okay, so not very difficult to find the area of a regular polygon. Okay, go ahead and do the examples, do the practice. This should be enough introduction for you. Okay.